but it says that a given locus with dominant genetic action and two alleles, if a suspected carrier of the recessive allele or a heterozygote passes the progeny test, what would happen? So if a suspected carrier passes the progeny test, I just want you to know what happens. And all these are based off of initial probabilities, or a lot of them are. So when looking at it, we see, let's go ahead and skip down to C, D, and E. The probability of being homozygote dominant based off a clean test equals 1. Remember, we'll never achieve 1. We will increase the probability, but our probability will never be 1 unless we have it genotyped, or it's like 0.99999 and we end up having to round it up, but it will never actually equal 1. It will never be 0. Our probability of being homozygote dominant based off a clean test, and that's just because it's a clean test. He passes a progeny test, like it says in the question, it will never be 0. We know here that it will actually increase our probability because we do pass a progeny test. That means there's no homozygous recessive offspring on the ground. And then probability will be the initial probability will be less than 0. That can't be true. We can't have a probability less than 0. So then we're on the 2. What does it do? What does passing a test do to the initial probability? Well, remember, it doesn't decrease the initial probability. So the probability of being homozygote dominant based on a clean test, it would not be less than your initial probability. You pass the test, you increase your probability of being homozygote dominant. So the correct answer choice here is B. So moving on to number 16, which of the following is not true about inbreeding? So A, individuals are inbred if their parents are related. That is the absolute definition of inbreeding. B says inbreeding increases homozygosity. We know that's true. That's why we talked about earlier about how inbreeding depression and heterosis, inbreeding depression and heterosis are exact opposites. Heterosis is the alleles being heterozygote, and inbreeding depression is due to the homozygous alleles. So we know that's true. C, offspring of inbred animals tend to be more similar than offspring of non-inbred animals. If I had a bunch of animals if I had one animal that was extremely inbred, and say that dam had 5 offspring versus a dam that wasn't inbred at all, and she had 5 offspring. For the inbred animal, because it increases homozygosity, you know what alleles will probably be passed down, so your animals will tend to be a lot more similar to each other than animals of non-inbred, or the non-inbred animals' offspring would be. So C is correct as well. E, non-inbred individuals can produce inbred offspring. Remember, that's true. Non-inbred individuals will produce, or they can produce inbred offspring as long as the non-inbred individuals are related. That's all the requirements are. And this one, inbred individuals will always produce inbred offspring. That's not true, because you can have 2 different lines, like line 1 and line 6 cattle. And you cross those, the offspring will not be inbred because those 2 lines are not related. So as long as, or you can have a completely inbred Angus sire, and you breed it to a completely inbred Hereford dam, and that offspring will not be inbred. So this one is not true that they always produce inbred offspring. They can produce inbred offspring, but if the animals are not related, then they will not produce inbred offspring. Number 17, heterosis, which is correct, has a positive relationship with inbreeding depression. Remember, it has nothing to do with, or it's the exact opposite of inbreeding depression. Has a large impact on carcass traits and a minimal impact on reproductive traits. That one's false. That one's false because remember, heterosis only impacts It has a large impact on reproductive traits. Hybrid vigor has an extremely large impact on reproductive traits due to not being heritable. Should not be considered in livestock breeding. Heterosis is an extremely important part of livestock breeding, so that one's not correct. Most of the time, it's detrimental to livestock production traits. That's not true either. There are times where it can be, but most of the time, it's very beneficial. So the answer choice is D. It's related to the amount of breed heterozygosity in the dam as well as the offspring. And all that's saying is heterosis is relative to the how much hybrid vigor is in the dam, so the maternal hybrid vigor as well as the offspring, which is your direct hybrid vigor. So the answer choice is D for that one. Number 18. All right, so this one, spider lamb syndrome is recessive lethal in sheep, like y'all should know. The ram's dam at the spider lamb locus, the probability of being homozygote dominant is 0.7. And then the ram's sire at the spider lamb locus, probability of being heterozygote is 0.6. What's the ram's probability of having the genotype big A, or his initial probability? So what's his probability of being homozygous dominant? Initial probability of being homozygous dominant. So remember, to find initial probability, we take 1 plus the probability that the sire is homozygous dominant plus the probability that the dam is, plus the probability of the sire times the probability of the dam, divided by 3 plus the probability of the sire plus the probability of the dam, plus the probability of the dam minus the probability of the sire times the probability of the dam. Another way to say that is just the probability of the sire and the dam. So this comes out to 1 plus the probability that the sire is homozygous dominant is not 0.4 or 0.6. Remember, because this is the sire is heterozygote, we know that's equal to 1 minus the probability is homozygote to equal the probability of being heterozygote. So that's going to be 0.4 is your probability of being homozygote dominant, or homozygote. So it's 1 plus 0.4 plus 0.7, probability of the dam, plus 0.4 times 0.7, divided by 3 plus 0.4, so that needs to be a plus 0.7 minus 0.4 times 0.7, and that gives us 2.38 divided by 3.82, and that comes out to 0.623, which is our answer choice C. And remember, right off the bat, you could have crossed out A and B because it is a recessive lethal. You want to know what the ram's probability of being that genotype. It's not going to be 0. If it is, that's only because he has the spider lamb. Remember, he's phenotypically normal. There's no way to know. There's not going to be a probability of being a genotype 1 unless you had this ram genotype, or you had the sire and the dam genotype to determine what they passed on. And then number 19, genotype and environment interaction. One of the following is incorrect. It is the norm, not the exception. This is 100% true. Most of the time we don't, I guess B says what I was about to say. Sometimes scientists and animal breeders ignore it, but it's still there. That's absolutely true. It's hard to measure genotype environment interaction, but we do know it's there. So both of these are wrong. Both of those are correct, but it's asking for the incorrect one. Line 1 Hereford or Montana-born cows had a lower pregnancy rate than Florida-born Hereford cows in Montana and in Florida, but the magnitude of the difference was greater in Florida. So this is saying that the difference between the line 1 and the line 2, even though there was a difference in Montana and Florida, there was a larger difference in Florida, which we could draw it out. If I said this is my Montana and Florida, and let's say, let me draw my line 1 Hereford cows. I'll do that in red. They had lower pregnancy rates. So Montana and then Florida. So I'm just going to draw that line right there. And I'm going to come over here and see my orange is going to be my line sits. So my line sits did have a larger pregnancy rate in Montana and Florida, even though it did decrease going to Florida. They did have a larger pregnancy rate, but since this difference is so much larger, we can tell that the differences aren't the same. It's a genotype environment interaction. So that one's correct. When looking at this next one, we'll talk about, let me draw the line 1 Hereford cows winged heavier than line 6 cows in Montana, but not in Florida. So this is just saying that line 6 winged heavier in Florida and line 1 winged heavier in Montana. These differences between the two are not the same, which means you have a genotype environment interaction between them. And then E, until the environment is genotyped, it will be difficult to effectively select animals for trait improvement. You can't genotype an environment, so that's why E is the correct answer for this, because it's the only incorrect answer that we have.